Hello everyone, myself Pragna from Sri Venkateshwara College of Engineering here to present you about the topic of network topologies. There are different types of network topology such as bus topology, ring topology, star topology, mesh topology and tree topology and at the last hybrid topology. Star topology. A star topology is the most prevalent network architecture. In the star topology, each network node is connected to a central device such as a switch, hub or a wireless access point, making it simple to add new node without having to restart all of the presently attached devices. When a cable in a star topology breaks, just the node attached to the cable is disconnected from the network. The other node can continue to operate properly. There is a relatively technically difference between a hub and a switch. To put it simply, a hub does not know how the computers that are connected to each of its ports. A switch, in contrast, is aware of the computers that are attached to each of its ports. Only switch-based networks have a real star topology. If the network employs a hub, the network architecture looks like a star but is actually a bus topology. Star topology are frequently used in local area network when you have a small network that utilizes a switch or hub to connect multiple devices. You can use star topology. It can achieve very high data transmission rate, especially when the star coupler is employed in the switch mode. This is the diagrammatic representation of a star topology. Bus topology. In the bus topology, nodes are connected in a line. To understand how a bus topology works, imagine the entire network as a single cable, while each node tapping into it listen in on the packet delivered over the wire. Every node on the network can monitor each packet delivered on the cable in a bus topology. Every packet is examined by each node to see if it is meant for that node. If so, the packet is claimed by the node. If not, the packet is ignored by the node. Each computer on the network will then be able to respond to the data delivered to it and ignore the data sent to the other computers. If the cable in a bus network breaks, the entire network is disabled. Because data cannot span the distance formed by the break, the nodes on opposite sides of the break can continue to interact with each other. Even nodes on the same side of the break may be unable to interact with one another because the open end of the cable left by the break disrupts the efficient transmission of electrical signal. The use of bus topology has various advantages. It's simple to add new devices, replace current devices, or uninstall old devices without impacting other connecting devices compared to other network topologies like mesh, star. Less cable is used and the cable can be quickly extended as needed. This is the diagrammatic view of the bus topology. Ring topology. Ring topology is another type of network topology. Packets are passed from one computer to the other computer in a ring topology. Each computer examines every packet to see whether it was meant for that computer. If not, the packet is sent to the next computer in the ring. Multiple LANs can be connected to each other in a ring topology on a larger scale using thick net coaxial or fiber optic cable. A ring topology, despite what some people think, is not a physical arrangement of network cables. Rings are a logical arrangement. The real connections are wired like a star, with each node linked to the access unit through its cables. In contrast, the network operates electrically like a ring, with network signal traversing along the ring to each node in turn. The most advantageous feature of the ring topology is the halving of the number of transmitters and receivers as compared to the linear topology. This is the diagrammatic view of a ring topology. Mesh topology. Each node in a mesh topology is connected to the other and can send and receive data as well as relay information from other nodes. Mesh topologies can be completely or partially linked mesh network. Mesh network topologies doesn't require physical layout, but each node must have multiple connections to the other node. Multiple LANs can be connected to each other in a mesh topology or on a larger scale using leased telephone lines, fiber optic cables, or thick net coaxial. The mesh topology is inflexible, poorly expandable, because new models must be connected to each of the existing nodes by a dedicated connection, which requires the installation of all the linkages before a new node can be added. The cost of cabling will be quite expensive for a broader region for the same reason. Along this design products a very reliable network. It uses a lot of wire and is channeling challenging to manage. This topology becomes more practical with Wi-Fi network. The benefit of mesh topology is that if one cable breaks, the network may utilize another path to transmit its data. This is the schematic diagram of mesh topology. Tree topology. We can consider the tree topology as an extension of a bus topology. It's a hybrid topology that combines the star and the bus topology. When the connection of the nodes are in a bus while the other child node spreads the connection into a star topology. The name of this topology comes from the manner in which trees are organized. The network is made up of additional nodes that are stretched outwards like a branches out of a tree, with a central node or core acting as the root or a trunk of a system. It commonly appears in cascading devices. For instance, if your repeater box has 6 ports and you have 6 stations, you may use it normally. However, if you need to add more stations, you may do so by joining 2 or more repeaters in a tree like hierarchy. Because of this great scalability, flexibility, tree topologies are popular among wide area networks. The most significant disadvantages of this topology is that centralization introduces the single point of failure problem. If the central node has issues or a slowdown problem, the entire network is affected and falls. This is the schematic representation of tree topology. Hybrid topology. We can consider the tree network as an extension of bus topology. It's a hybrid topology that combines the star and the bus topology. When connection of other nodes to the core node acts as a bus while the other child node spreads the connections to its star topology. The name of this topology comes from the manner in which trees are organized. The network is made up of additional nodes that are stretched outwards like branches out of a tree, while a central node or a core node is acting as the trunk or the root of the system. It commonly appears in cascading devices. For instance, if your repeater box has 6 ports and you have 6 stations, you may use it normally. However, if you need to add more stations, you may do so by joining 2 or more repeater in a tree-like hierarchy. Because of their great scalability, flexibility, tree topologies are popular among wide area networks. The most significant disadvantages of this topology is that centralization introduces a single point of failure problem. If the central node has issues or a slowdown problem, the entire network is affected and falls. This is the diagrammatic representation of hybrid topology. Thank you.